So last week we worked with solving equations and we learned about proportions, okay? So we're now going to be given equations and we're going to solve equations for the variable that it's asking for. So there's going to be more than one variable in these and we're going to solve for one of them. All right, and then we're going to use formulas to solve real world problems, okay? So here is an example. We are given this equation. There's a b and a c, and it wants us to solve for just b. Okay? So when it says solve for a specific variable, what's the ultimate goal?
To get find c.
To get it by itself, right? Find a value for that variable. Okay? So really, are we going to find values today? No, because look what our answer is here. We're just going to be solving for a different equation for that variable, okay? Because there's another variable in there, so we are not going to be given an actual answer for this. So on this one, I know it already gave you the answer, but let's walk through it. It gives us this equation, 2x minus 17y equal to 13. Wants us to solve for y. What's our goal?
To get y by itself.
Get y by itself, okay? So I'm going to underline our y here in a different color. What is our first step to get y by itself? Subtract what?
Subtract 2.
Yep, we're going to subtract this 2x over to the other side. Subtract 2x. So this side it's gone. On the left side we're left with 17y, negative 17y. What do we have on the right side?
11x.
Careful. Can we combine those? No, because they're not like terms. Yeah, just leave it. 13 minus 2x. And then what's our last step to get y by itself? What's our last step? Yep. Divide by negative 17. Divide by negative 17. Since it's a negative, what do we need to do to the top? We got to switch the signs on the top. So we're going to have negative 13 plus 2x divided by 17.
Yeah.
So I flip those signs because I divided by a negative. And then our answer, they already told us, is C. So once we get our variable that we want and it's completely alone, even though no matter how messy the other side looks, that's our answer. Okay? Any questions over this? Do some more practice. If I had the same equation, E equals mg, how do I get g by itself? What do we normally do when we have a fraction? We're still going to multiply by the denominator, okay? Still, even though we're really getting m by itself, still do this step, okay? So I multiply by g on both sides. Everyone with me? And then I have g equals m. Can I still get g by itself?
Yes.
How would I get g by itself now?
By e.
Divide by e. And then I would have g equals m over e. So there was just a little step in there, okay? But still, when you have a fraction, you still want to get rid of that denominator, even if it takes you an extra step to get that variable by itself. Okay? So it's a little bit of trial and error when you're solving for these. All right? Go to page 6 in your notes. So if I'm given this equation here, going away from the notes a little bit. If I'm given this equation here, how would I solve for m? How would I get m here by itself?
Multiply m and e.
Why do I times by g? Why do I multiply by g?
Get rid of the denominator.
Get rid of the fraction, right. So multiply by g on both sides. Over here, the g cancels out. So over here, I'm left with eg equals m. Am I done?
Yeah.
Why am I done? Because m's completely by itself, right? Okay, let me... come over here. If I had not this one, we're given a little word problem. If Quanah, did I say that right? If Quanah drove 1,477 miles and her pickup has an average fuel consumption of 19 miles per gallon, about how many gallons of fuel did she use? How would I set this up as an equation?
19x.
Right, why do you say 19x?
Because it's asking per gallon, you don't know how many gallons.
Right, you don't know how many gallons, so remember whenever you see that per, that usually means multiply with an x. And that equals what? 1,477. Now it wants to know how many gallons, so how do we solve?
Divide by 19.
Divide by 19.
That's easy.
It already gives us the answer. It is C. Okay, so you'll see problems like that where you set up your own equation and then you solve your own equation. Okay?
Yeah.
I'm not going to talk too much about this, but I do want to mention it. Dimensional analysis. Anybody have any idea what dimensional analysis means? No.
The weight of a chimpanzee.
What does analysis mean?
Analysis, quantum.
You analyze data.
Yeah, you analyze data. What does dimensional mean?
Like the dimension of it.
Okay. Kinda. How do we get from inches to feet? We have to go through different conversions, right? So here, how will we get from, it starts us with kilograms and wants us to get to pounds. How on earth do we get from kilograms to pounds? It's a great question. We have to go through dimensional analysis to get there. Okay? So, this chimpanzee, it starts us at 52 kilograms. So that's where we start. 52 kilograms. Now we need to work our way from kilograms to pounds. So our next one is going from kilograms to grams. Well, it tells you how many grams are in 1 kilogram. 1,000. So you set it up 1,000 over 1 kilogram. I'm going to talk about something else in a second. So now we're here. Now our next dimension is ounces. It tells you here that we have 0.0353 in 1 ounces per 1 gram. Okay? And then our last step is to go from ounces to pounds. And it told us a hint here. It gave us all these hints actually. 1 pound equals 16 ounces. Why do you think they set it up this way? Why do you think they set it up this way? Think of the labels. What happens to the labels when you multiply them?
Oh, wait, it's part of it.
Huh? What'd you say? It does. How do we get from kilograms to pounds, though? Like, what happens with all the grams and the ounces and all of that?
Simplify.
How does it simplify? Remember, this treats it as over 1. What happens to the kilograms here and here?
Oh.
What happens?
They go bye-bye.
They all cancel out, right? If you divide a kilogram by a kilogram, you're left with 1, right? Just like when you divide 2 divided by 2, you're left with 1. So all those labels go bye-bye. And then you're left with pounds, and that's what we wanted, right? Yeah. So dimensional analysis, that's why they set it up, so they can get rid of all of those different variables. And then you're left with what you want. Okay? Not going to go too in-depth with this stuff, but I do want us to understand what happens. Okay? So, if we go to this last one, think about this for a second. Okay. What does she start us with?
20 laps.
20 laps. Bingo. 20. I'm going to put an L for laps. I'm going to put it over 1. What does it go to next?
Meters.
Meters per how many laps? 1 lap. So how would I write that as a proportion?
350 over 1.
350 over 1. I'm going to put an M for meters. Why did you line it up that way? How did you know to put 350 on the top?
Because it's how many meters are in the lap.
Right, because the laps eventually, right, these will cancel out, and that's what we want. Okay, what's next? What does it tell us is next?
Yards.
Yards.
No mile. How many miles?
It wants us to get to miles, but here, from meters, we have to go to yards first. So how would I write this?
1.094 over 1.
Yep, 1.094 over 1, and that's yards and meters. Good. What happens? How do we know we're right?
Because the one case.
The meters cancel out. Good. What would I do next?
1,760 yards over 1 mile.
1,760. Careful.
Wait, flip it.
Right, why do I have to flip it?
So the yards cancel out.
Yep. So we have 1 mile over 1,760 yards. How do we know we're right now?
The yards cancel out.
They cancel. What did we want to get to? Miles. So are we done?
Yeah.
Now we can multiply it all out, right? Because we're left with the mile that we want. How do we solve this?
20 times 350.
Type it out. Type it out in the calculator. Help me out. Yep, we're just multiplying straight across now. So we have 20
350.
times 350 times 1.094.
That's it?
I don't know, is it?
Yes.
Do we have anything left on the bottom?
No.
What's here?
Oh, 17.
So you got to divide by 1760.
4.35.
Bingo. So really, is it that difficult? No, it's just a lot of steps, right? Just getting there. But as long as you have it all lined up correctly, you're good. Okay? Any questions with dimensional analysis? No? All right.